get into a dammed system and impoundment, then it can start to look and act like a lake, for sure. And that's what happens in the lake is it changes top to bottom, depending on the time of the year, and it flips at times of the year as well. So linking our oxygen with plants and animals. If you have a lot of oxygen, again, your trout are happy. The sculpin that like to live in the streams with the trout are happy, and a lot of plant variety, which makes sense because they're making the oxygen. At the other end of the scale, your carp. Oh, who asked me about green sunfish? All right, they must be hardy. They're at the low oxygen level, so they're going to be able to survive at lower levels. Fathead minnows, they're in a lot of streams, and less plants.
I don't know what green sunfish are.
They look like bluegills, but they don't have the blue ear, so the green tinge, but they pretty much look like bluegills. So looking at our dissolved oxygen, I split it up for the pie charts by these 4 categories. The trout water is above 6, 5, 3, and 1 milligrams per liter. So most of our samples, both statewide and in Waukesha County, are good. What you all are seeing is good. Again, we're going to go to what's a possible weakness is, did people go out in the morning? If you went out in the afternoon to monitor oxygen, and you're telling me it's above 6, that might not mean much, because I want to know what happened, what's the worst conditions that these organisms are facing. So if you can go in the morning and you haven't been, that's the time to go. The thing about dissolved oxygen in terms of data use, your point in time dissolved oxygen data are most valuable that day. And if there's a problem, we would like you to tell people that there's a problem, because the biologists, I think there's 12 maybe biologists that work for DNR in the state, they can't be at all 84,000 miles of stream, which is where you all come in to help identify if there's an issue. And so in this case, we're only seeing, say, 0.15% that are, or 0.15%. See if I can do my colors. Fisher Farmland, my colors are really bad because they're like the same. Apologies, I think that was an accident. In any case, really small percents of what you're observing of bad oxygen, but that's what we want to know. When you see it and if you see it, that's what would like to be reported. So let's look at your data from the sites that are here. So we're seeing, for the most part, again, the means here for above 6, everybody looks good. But there's a couple sites, here, here, and here, where maybe there was a phone call that could have happened to tell somebody, hey, I'm seeing something that could be a problem today. If we're below 4, that's when it starts to get to be a problem for the aquatic life. So my message there is, if you do get below 4, first repeat the test, whether you're using a meter or the HOC kit. If it's still low, then please call. Either call Jane or we have a website, which it's cut off at the bottom down here, but on the Water Action Volunteers website, this is for Waukesha County, so these are your people that you would call. There's also a DNR tip line, 1-800-TIP-WDNR, where you can call and say, I have observed low oxygen. Volunteers have been the first to see when there's a problem and have identified fish kills that are coming, essentially, or have identified illegal discharges. And companies have been fined based on having that been figured out what was causing the low oxygen. Sound good? Okay, for habitat, how many people do soft habitat assessment forms versus rocky? Yeah, soft? How many people do rocky? I'll tell you in a second. You'll know what you do because I have it plotted. The big thing about habitat. Oh well, you don't because Jane.
Because I had done those. They're,
okay.
Yeah.
Yes, you don't even know. Okay, so here's the deal. Habitat is just looking at the stream bottom, the banks, and alongside the stream to see how good it is for aquatic life. The reason that we're changing our habitat assessment this year, in the past, it's always been volunteer-specific form. It's 10 questions that you answer. We're actually shifting over to use the same habitat form that the Department of Natural Resources biologists use. And as Jane said, we're trying to align the volunteer program better with what the department data needs are. So we say, okay, we're just going to have the volunteers use the exact same form because that makes sense to our biologists and what kinds of answers you're getting. So that will change over time. So there's two kinds of forms, if you have a soft bottom or if you have a rocky bottom form. So in Waukesha County, slightly more soft bottom assessments than rocky bottom assessments. The range that you can get of habitat is 13 at the low end to 52 at the top end. So we've seen pretty much the whole range for the rocky habitat assessments, both statewide and in Waukesha County. For the soft habitat assessments, we haven't seen the lowest for our soft habitat assessment in either place. So here's the sites that were done for the rocky habitat assessment, looking pretty good. They're quite right up near 40. The test corners, that's yours.
Yeah.
Not looking so great.
A lot of erosion there.
Okay, there we go. A lot of erosion. And then if you look at the soft habitat, those ones actually look pretty good. Again, 52 is our top. So pretty much every site except for two, Pewaukee, Capitol, and Zion, are right up there looking good for the habitat assessment. Okay, so stream flow. This is one where Jane mentioned that we're looking to try to get more stream flows from the volunteers, and that's based on the fact that the Department of Natural Resources permit reviewers for high capacity wells or for irrigation wells, they often don't have data about places, and they only need data that are good to order of magnitude. Is it 1 cubic foot per second? Is it 10 cubic feet per second? Is it 100 cubic feet per second? Just to give them an idea to get started on their permit reviews. So they're looking to try to get more flow data so they can have information to inform their decisions. So this is one where the pie charts, well, they are what they are. So we know statewide, 7% of the sites are really tiny, and I'll show you a picture of what size these are. 8% in Waukesha County. We know almost 60% statewide are the biggies, over 10 cubic feet per second, and about half of Waukesha County are over 10 cubic feet per second. So what do those look like? Tiny, 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 0 to 1, like this deep, like this wide, really little. 1 to 10, the middle picture, and then greater than 10. The one that's there is about 125 cubic feet per second, just to give you an idea what it looks like. So what I know from Waukesha County is mostly folks are monitoring fairly small streams, which is good, actually, makes me feel safe, because you can wade in those pretty safely. None of them are outrageous. The Bark, I can tell, is a bigger stream. It's up by the 130 or so as a mean. So that's a bigger river. So for pH, for people who are doing the level 2, we know pH is acidic to basic, 1 to 14. It's a logarithmic scale. So if you go from 6 to 7, that's a 10 fold increase in the hydrogen ions. We know that in southern Wisconsin there's a lot of limestone, and so if there's something that's coming in as acid, whether it's rain or some other off the land source, we know that the limestone is actually going to not let the water's pH change very much as compared to northern Wisconsin, which is granite, and that's not going to have a buffering ability for pH. If there's something acidic coming in up there, it's going to change the pH of the water much more readily than down south. If the pH does change, metals as ions are going to be more freely available, and it's going to change the nutrient availability within a stream of certain kinds of nutrients. So we know that there's a state standard for pH. It's between 6 and 9, and basically we're just looking to see if people's pH lies within that range. Thinking about what it means biologically, I tried to make it so you could read it, so it's a little bit funny. So here's our tolerance range for fish. They're about between 4 and, I think it's the 9 line, or 10. 4 and 10 for fish. Wisconsin's standard is 6 to 9. And then optimal fish are probably pretty happy, just above 7, just above neutral. But things, when you get down towards the acidic side, you're going to see salmon eggs could start to die, bass and trout start to die, caddis and mayflies start to die in this 4 to 6 range. So we're not seeing those numbers really at all in Wisconsin. But if we did, that's what could happen biologically. So what you're seeing here for sites that do have the pH, I only put the state standard range here, and everybody lies within, you're in that happy range for the fish, in that just over neutral level. I was surprised though that there was a range. It's a little bit wider because again, if you're going one point is actually quite a jump in pH. So for instance, Battle Creek at BB, it's kind of it's a big range for what you're seeing for pH over time. For temperature. So again, temperature is related to organisms' survival or presence. Trout, for instance, want cold water because there's lots of oxygen. Temperature, if there's high temperatures, things are going to respire faster. Chemical processes are going to go more quickly. Plants and animals will react to temperature in that way. Temperature is also important in terms of climate change, what's happening over time. And I wanted to share with you that one way that your data, for folks who have done the level 2 with the thermistors, the data have been fed into this Northeast climate study, which is northeastern United States, that whole blue area on the map. And so they're looking at what's happening with climate change over time. And one of the things that we're trying to do this year, another change to the program, which is a little bit minor, is rather than just having the thermistors in from May to October, we want to leave them in year-round, and we're going to try to stagger it so that everybody gets to pull them and put them back in a nice warm month rather than sending you out in the freezing cold runoff in the spring or in the winter snow right before snowfall. So if you are somebody who does a thermistor in your game to do it year-round, that's something we're going to start to do, and it's based on feeding it into the climate change studies. The one risk we have is that there could be ice in the winter that's going to send them off to Illinois or wherever they might go, but we're going to take the chance to hopefully not lose too many. So thinking about what it means for the different organisms, and I've said it already, the trout, they like it cold. If you think about some of your insects, and this is research I looked at again through the research, mayflies, stoneflies, and caddisflies, they're okay a little bit warmer. I apologize, it's all C, sorry. So 10 is 50 degrees Fahrenheit. 21 is 70 degrees Fahrenheit. 30 is call it around, is it like 80 maybe? Yeah, give you that conversion. So our bass and sunfish and catfish and our mayflies and bass, sunfish, and catfish and darters, they like it warm. But some mayflies, the stoneflies, they're going to start to die when it gets up into that 70 to 80 degree Fahrenheit range. They like it more in the 50 to 70 range. One of the other things about temperature is there's stream classifications in Wisconsin. There are cold, cool, and warm water streams. So there's a definition in the state, and it tends to be that we use the one over here. Rather than an instantaneous, we can use instantaneous for those who are doing instantaneous temperature, but when the DNR staff are doing actual classifications, they use your continuous data for temperature, and they look at what's called the maximum daily mean. So they say, okay, over all these days, how warm did it get as an average? What's the maximum average that we saw at that site? And then they can decide if it's a cold water stream, it's going to stay less than 72 degrees Fahrenheit. If it's a cool water stream, it will be a little bit more than 72. And if it's a warm water stream, it's going to be more than 75 degrees Fahrenheit.
When you say trout died, how quick did they die?
I would
mean,
say
a few days?
Yeah, I mean it's probably the studies are probably done in a tank, so I don't know for sure what the answer is. In real life, the fish are going to try to swim away as much as they can to get out of that situation, and so they may not necessarily die, but they might leave. But in terms of death, I don't know the answer to that.
20,
Do you
20
know?
you get up to about 25 or 26, And if they've got no place to go, they're belly up pretty quickly. And that I've seen that, for instance, in the Mukwonago River, where seeing brook trout go in, even with acclimation, at about, oh boy, I think it was about 24, and they did not do very well. They just cannot, when the temperature gets that high, there's just not enough oxygen in the water to support them. And
So a couple days or what?
no, 15, 20 minutes.
Really?
Yeah, I mean, typically when you see fish kills because of low dissolved oxygen, they happen pretty quickly. And that, it's
Yeah, well, and one of the things like low dissolved oxygen too, like we were at a site a couple summers ago and we had oxygen levels of 0.17 milligrams per liter. So basically no oxygen in the system. So in that case, it's a little bit different than a warm water situation. It was a whatever, there was a chemical in the system, so there was just nothing there to breathe. So that makes sense where you would just go belly up if there's nothing. So it depends what is the level of the oxygen. If it's a temperature-based thing, it may not be as low as 0.17, but if there's a chemical and temperature connection that's making it that low, then it could be.
So what's the range of carp?
For their
Temperature.
For temperature, I don't know. Do you? I don't know. I'd have to.
Yeah,
go to
the only
papers.
the only place I have ever seen carp stressed is there are some ponds. If you know what wing spread is down in Wind Point, it's at Johnson Foundation's headquarters. They have some ponds that were warm enough and low DO enough that the carp were actually coming to the surface and gasping for breath. It was.
Wow.
Yeah, those ponds are in pretty sad shape, but
I'll think about it.
Yeah, so I
That's
don't know
the
for
only-
sure. Yeah.
it's the only time I've ever seen carp
Yeah,
stressed.
right, yeah. So I don't know for sure for temperature. So what I did is I took the folks who have level 2 site data, and these are in your reports that I handed out, the last page. What the reports do is they plot out your continuous temperature data over time. So the dates are hard to read because there's a lot of them, but for instance, this is for Bark River Genesee. It started in May of 2006, so this is only, looks like it was just 2006 that they had a thermistor in. The orange line is our cool and warm water classification, so above this would be warm. This is our cold water, so below this is cold, and in here is so here's warm, here's cool, here's cold. That makes sense? Okay, and then the line that I think we want to look at is our green line, because that's our daily mean temperature. So the maximum daily mean temperature is what we want to know. If we ever see the green line go above the blue line, we know it's not a cold water stream. If we see the green line go above the orange line, we know it's not a cool water stream. So what do we have at the Bark River Genesee? Do we have cool, cold, or warm? Where does our green line go above? Is it cold? Does it go above the blue? It does, right? So we know it's not cold water. Does it go above the orange? The green line? So right here, it's above the orange, right? So it's, and above here, yep, you're right, a couple times. So at least twice it goes above the orange, which means we're in a warm water system on the Bark River.
But that's July and August.
It is July and August, but in a trout stream, there's groundwater feeds, and so it will be 50 degrees Fahrenheit. It will stay cool no matter what time of year it is. So let's look at one other thing to keep an eye on that I thought was interesting. This one doesn't show it, but because it's only 2006, for some of the sites that have multiple years of data, we're going to look at what happens over the years and see what's happening with temperature, which I actually found very interesting over time.
Bark River should have multiple years. That's,
It could be that's good. Remind me of that when I write it down. The report, some of the reports seem to be working right and some of them don't. So if it's not working right, I need to go back to the programmer and say, hey, it's not pulling the data, and I don't know why. But remind me, because I want to tell the programmer that. So this one, we've got Mason at Peterson, 2012 It's only 2012 in this case. So we see our blue cold water, our warm water line, and again, we just barely, in this case, get up in that warm water system with the green crossing. But then what's happening, so this is only 2012, it's getting colder as we get into the fall. So we start in June and we go to October, so that makes sense. We're getting colder in the fall. That makes sense? You see a generally decline. And you see the up and down, you're seeing daily, it gets colder at night and warmer in the afternoon. Okay, so we've got Bark River County Road P, lots of data, 2011 all the way to 2014. So this is one where it is pulling all of the information. We start in April and it ends in October over that way. So in this case, again, we're seeing green line, it's warm water, right? The green goes above the orange, so we're seeing warm water. And you see, do you remember 2012 was the drought year? A little bit warmer in 2012 than in 2013 and 14. Probably more water in the system. Then getting dried out. I remember, Jane, we had to fix the database to allow it to enter crazy numbers. Cocoa Creek at Yent. So here's one where our green is mostly below the blue, right? Except right here and right here. And this is 2010. But in this case, we've got a cool water system according to the temperature that's being collected with the thermistor. Because the green never goes above the orange. That makes sense? Oconomowoc West Shore. So this is one from 2012 to 2014. I think it's getting colder. Again, possibly because it was a drought system, or drought year here, when it was less water, easier to heat up if it was a shallower system. And here, it's clearly a warm water system. We got green above, and then 2014, it's still above, but it's not so above as it was in 2012. So, I think that the data that you all have collected, that the streams are looking, in general, they're looking pretty good. They're in that fair range. There's certainly some issues to watch for those dissolved oxygen sites. There's some of the biotic index samples look, 1 out of every 5 indicates poor water quality, and that's where I already said, is it a timing thing? Is it when we're going out to do the collection? I don't know, and I could dive more into the data and see if we can start to figure out what's happening with that, or if it's truly that the sites are showing that it's poor water quality. The temperature patterns over time, I'm going to take back what I said. I mean, it makes sense. Well, I won't take it back. 2012, I think, was that drought year, so we were seeing warmer temperatures to 2014. I tried to add in a slide, but it wouldn't load. I was going to show you what the data sheet looked like, but in any case, you don't need to see it. You'll see it later if you want to see it. So you've been asking questions as we go, but do you have other questions at this point?
Has the data shown that streams are warming through the years? I mean, like what Ricky says,
So the data that we have that I just looked at, I don't think if anything, it's looking like it's cooling, which is what I thought was a little surprising. But then I said, okay, well, it must be because of the drought year in 2012 where things were looking a lot warmer, and maybe that thermistor was closer to the surface or whatnot, or the stream was shallower. But we only have 3 years of data, and I didn't look at broader. So in the data set that you all have collected, no, it's not showing that. But 3 years, we'll have to see after 10 or 20.
You need a lot of data, and you need a long data record to detect those kinds of changes. This is very noisy data, and getting trends out of that noise is not easy anyway. To find that sort of trend into this sort of stream data, you need some very powerful statistical methods, and they're just, none of these sites have enough data to see that signal.
Long time periods, right? I mean,
Yeah,
we can,
and long time periods, and in general, our water quality data set in this part of the state only goes back to 1964.
it's probably true most of the state, yeah.
Yeah, and
And
that's a long one, and that's mostly because of the sewer pack benchmark study that was done in 1964 and 65. So, you know, in most of these systems, we just don't have the data.
Well, and I would say statewide, there's, what the biologists are able to do is they don't monitor anywhere near 655 sites in a state in the year. Long-term sites, there's some long-term trend studies where they do maybe 50 sites statewide, and they've been doing that since maybe
Yeah.
the 60s, maybe the
Yeah.
50s. So this is just like the volunteers being involved in collecting information is expanding the data set by so much. And you know, I want to be cautious. I don't want to tell you that your dissolved oxygen data are going in and being used for making management decisions for listing a water body as impaired, because point in time dissolved oxygen data, the reason they're important is if you tell us, hey, I think there's a problem today, and then somebody can go out and try to address it. Versus if you're doing continuous temperature data, that could feed into a warm, cold water classification over time, or climate change research in the future. So the different kinds of data are going to be used in different ways, but you are definitely building on a small data set from what the biologists are able to do on their own.
Some of these data sets are very small. I just worked up for the stream plan that we're doing for Mason Creek. I just worked up all the data a while back, and not just the wave data, I mean all of the available data, and I had fewer than 110 water quality samples in the whole watershed. That's small even by what I do. I did the Root River watershed, and going back to '64, I had 15,000 samples. And again, that's a small data set.
Chris, I have a question. You went back to calling you, or making a phone call immediately. And why is it so important to jump on a change?
If you see a low dissolved oxygen?
Yeah.
So because there could be a fish kill. So I'll give you the example of where somebody was fined. There was a company with an illegal discharge, and it was causing low dissolved oxygen, which can cause a fish kill. So the idea is if somebody notices it soon, then something might be able to be done. Say it's a manure spill, maybe it can be stopped before it gets worse, and then put a barricade or stop the discharge, stop it from happening, and hopefully minimize the fish kill. So the idea is that at that level, there's going to be a fish kill, and let's see what we can do to minimize the impact of that by telling somebody who can then take action to figure out what the heck is going on. So that's why it's an emergency, if you will.
Can I take one question?
Sure.
In certain portions of the state, people's water table is really being poisoned because they have these cattle farms of 3,000 to 8,000 cows, which the state is okay. Yet if you talk to the local people, so how would you even measure that in the water table? That would all drain into the stream?
So you're like the manure.
They just have too much
runoff.
manure to get rid of.
So measuring it in a number of different ways. So you could measure bacteria levels in a stream, and if bacteria levels, there are standards for bacteria. If it's above the standard, then something needs to be done to address the source. And so if they can trace the source, which would likely be a cow, then they can do something about it. There could be other methods, so like phosphorus is one that could be linked back to agriculture. If there's phosphorus issues, which there are in many places in the state, then what's written is called a TMDL, a total maximum daily load, which is a report that basically says there's a pollutant, and this is the amount of the pollutant in this water body that makes it a pollutant, and we need to make a plan to clean it up so that whatever we're doing to cause that pollutant to be at that level is not happening any longer. So, for instance, in the lower Fox River Basin, they have a TMDL for phosphorus, total suspended solids. Phosphorus moves connected to sediment. So they currently are implementing their TMDL plan so that sometime in the future, I don't know if there's actually an end date when they're planning to have it clean, but theoretically, what is supposed to happen is they are supposed to do stuff on the land that makes it so that they no longer are polluting the stream with that phosphorus. Same thing would happen for bacteria. The state is required every 2 years to submit to the EPA, the Federal Environmental Protection Agency, a list of impaired waters and by what means it's impaired. So they would say, okay, this water body is listed for bacteria, for temperature, for resistant solids, for phosphorus, and when a TMDL is written, that's supposed to then spark action on